of our research. I'm a coordinator of our research group on forest history and traditional knowledge. Because this is a IUFRO event, and to fill in the time while we wait for people to come in, IUFRO always wants us to give a little presentation, a little publicity thing on IUFRO. So bear with me. This is one of the things that we do for IUFRO to provide a little bit more information for people who don't know. So IUFRO is a non-profit, non-governmental, international organization of people, of researchers working in forestry. They're headquartered in Vienna in Austria, but really they are all around the world. This is a little slide that sort of shows some of the numbers for IUFRO. So overall, we're talking about more than 15,000 forest research scientists. And that's a lot of people, and that is what really makes, I think, IUFRO unique, is that it's got an incredible force, a wonderful place for networking and for opportunities to finding other people in other countries. There are 115 odd countries, and being involved with them. And there's IUFRO in a typical year will have somewhere around 70 or 80 meetings happening in different parts of the world. I've said international and around the world, so this is just the number of IUFRO member organizations. So probably 15,000 forest researchers in at least 630 different member organizations. So that's mainly universities, government-run forest research institutes, and so on. What does it actually do with all of these people? Well, that's sort of roughly what we've got. There are divisions and task forces. It's not really my goal to go into all of this, so I'm going to pass that slide. The heart of IUFRO happens across 9 divisions, which bring together researchers in different areas. So at the moment, we're in Division 9, which is on forest policy and economics. And within Division 9, there are 6 research groups, including this one, which is forest history and traditional knowledge. And then within each research group, that is then split into working parties. And so there are 2 working parties that have collaborated today to bring this event together. The groups on the working parties on historical ecology and biocultural diversity. And so that's people like Antonio Santoro, Agnes Mwambe, Mauro Agnoletti was involved in this for many years. Doris Mutter is also among the people who have got a lot of experience and history within IUFRO. What do we actually do with all of those people? Well, the biggest thing each year is the conference, which happens every 5 years. And so the next 5-yearly conferences are going to be in Nairobi in Kenya. And that was one of the reasons that we're really very happy that we've got KEFRI, the Kenya Forest Research Institute, is collaborating on this project, on this webinar today. There are meetings and workshops probably each week somewhere in the world. There is some form of meeting happening or organized by IUFRO, whether it's a webinar like this one, a physical meeting, a group of people meeting together virtually, a lot of things going on. Task forces bring together across divisions. So most of the work happens within divisions, but task forces that work across divisions. And the number of communications that come out through IUFRO, whether it's reports that are produced by IUFRO, special issues of journals, webinars like this one, podcasts, stuff coming out all of the time. So in a nutshell, that's IUFRO. Our goal is not really, if you want to get involved, contact any of the people who are involved. You can reply to wherever you got this email from, and we will quite happily give you more information. The website is there, and then you also find them everywhere that you find information and groups now. So with that, that is what I have to say. I'll pass you over now to Antonio Santoro at the University of Florence. Antonio is the main person who has been leading this webinar, and Antonio is the coordinator for one of our research group, for one of our working parties, and so he's He's the one who has taken on all of the work on this from research group 90303, which is Historical Ecology. And that's also where Mauro Agnoletti previously was very involved in that for many, many years. So with that, I will stop sharing my screen and I will pass you over to Antonio. Antonio, to you.
Yes, thank you, Stephen. Thank you for your introduction to IUFRO. And I will briefly introduce the theme of this webinar. Today, the webinar will focus on the role of trees within agricultural areas, because trees in agricultural areas play a key role in the lives of rural communities all over the world through provision of different goods and also ecosystem services. So besides providing food and materials, they can have important roles as a part of wider ecological networks or for reducing soil erosion and hydrological risks. They provide shade and additional fodder to livestock, improving their well-being and productivity, and they are crucial for the preservation of traditional cultural landscapes of great aesthetic and social value. So they are really important in different parts of the world, and the management and presence of trees in agricultural areas is often also related to traditional knowledge. And so they are also important for the local cultural heritage and for the sense of place. But trees in agricultural areas can also be important for the future of our rural areas, especially in the framework of climate change, water regulation, and to build more sustainable agricultural and agroforestry systems, with also a positive impact both on the environment and on the well-being of the rural communities. Unfortunately, they are often not properly accounted for in agricultural or forest inventories or statistics, so it's difficult to make reliable estimates of their presence in many rural areas. Therefore, multidisciplinary research on this topic is necessary, and also awareness-raising activities and information, giving the connections between ecology, history, anthropology, and landscape, and also the introduction of innovative management and monitoring system can help in make these tree-based systems increasingly sustainable and widespread. So the webinar will address the importance of planting, managing, and preserving trees in farmland with examples from different parts of the world, and is part of the different activities that IUFRO is carrying out, also as a path toward the next IUFRO World Congress that will take place in 2029 in Nairobi. So thank you for your attention. I'm really glad that to have all you here connected to the webinar. And before starting, I really want to thank the moderators of the webinar, Professor Stephen Wyatt and Professor Agnes Mongombe, who supported this webinar and the organization of the webinar. Let me also thank all the speakers that accepted to the invitation of participating to the webinar. Bridget Burger from IUFRO from the support and the dissemination activities, Professor Lorena Sabina from the University of Philippines, Los Baños, who helped in organizing the webinar, and my colleague Francesco Piras from the University of Florence, who contributed to the organization and today is in charge of the technical part of the webinar. So thanks a lot to IUFRO for the support, and I hope you really enjoyed this webinar. I will pass to Stephen for the introduction of the first speakers. Thank you.
Thank you very much, Antonio. It's my pleasure to introduce our first speaker today. In fact, we have a really good lineup of speakers for you. So thank you very much to all of our speakers for contributing. But we'll start the ball rolling with Dr. Dennis Garrity. Dr. Garrity is a systems agronomist, a research leader who has spent his career working on small-scale farming and systems across the tropics. He sort of gave me a short list of his different roles. So I'm just going to pull out a couple of those. The Global Evergreening Alliance, which brings together 106 member organizations around the world. The Healthy Planet Action Coalition, which has got about 250 scientists and influencers. He's a past Director General of the World Agroforestry Center, better known by many of us as ICRAF. Drylands Ambassador for the UN Convention to combat desertification. Amongst all of these organizational roles, he's continued to publish actively with more than 200 odd publications to his record. Dennis, I don't know if you are planning on taking a retirement at any time, or if you're just going to keep on going. That's what I suspected. We are very lucky to have you here today. Thank you very much for joining us. Francisco, if you can please put Dennis's Dr. Garrity's presentation up on the screen. Over to you, please.
Well, thank you, Stephen, and a special thanks to IUFRO and especially Antonio and Agnes for this invitation to share some reflections with you on how to expand agroforestry systems in the face of accelerating global heating. Now, in 2011, I retired after a decade as director of the Agroforestry Center in Nairobi. And at that time, I had then been working in the Global South for about 30 years beyond my PhD in Africa, India, Indonesia, and the Philippines. And I then embarked on another journey, which has carried me along during the past 13 years. Next slide, please. I was acutely aware of the enormous areas of degrading and degraded land in the world. Next slide, please. Degraded land. Okay. In the tropics, as you saw on the map, there are massive red zones across the developing world, about 2 billion hectares of degraded land. And I had learned a lot about the potential for restoring that land through agroforestry and better forest and ecosystems management. The World Agroforestry Center had bilateral relations with hundreds of organizations, and we were working with those organizations for many years, but I recognized the possibilities for creating a new model of land restoration and bringing these organizations together as a united coalition to focus on this. So I set out to build a global coalition of development organizations and research organizations to focus jointly on supporting rural communities, particularly smallholder farmers, in building a new model of large-scale land restoration. At first, it was an informal network, but in 2018, we established it as a new international organization, the Global Evergreening Alliance. Next slide, please. The Alliance now has 106 member organizations, and yes, we're on the right slide now, and a portfolio of major programs. The scale and capacity of these organizations has attracted the upfront support of major corporate investments from companies who are committed to offsetting a small part of their carbon emissions through assisting smallholders to develop their agroforestry systems. Next slide. Our signature program is called Restore Africa. The Restore Africa program is the world's largest community-led, nature-based carbon removals program. And it currently spans 6 African countries and is growing all the time. Right now, we also are supporting over 1 million, 1.5 million smallholder farming families and restoring over 1.8 million hectares of land. A similar program is currently launching in Southeast Asia as well. Next slide, please. To address our global aspirations, we've developed unique strategies for forest lands, farmlands, and rangelands restoration. For example, we aim to restore tree cover on 575 million hectares of degraded forest lands. On farmlands, we aim to triple the rate of carbon accumulation on 500 million hectares of degraded farmlands. And on rangelands, to regenerate a healthy grass-tree balance on 650 million hectares. The white paper containing the full analysis of these goals is accessed on the landing page of the Global Evergreening Alliance website. Next slide. Now, we set out to mobilize the entire global community to collaborate in achieving these goals, including the public, policymakers, and private sector partners with practical solutions toward a common goal. We've partnered with many other international restoration efforts, particularly with the UN Decade on Ecosystems Restoration. This year, we were asked by the UN Climate Change Convention to coordinate the new global roadmap for sustainable agriculture and land restoration, which was gavelled in for implementation at COP30 in Belém just last week. Next slide. Now, we calculate that this global effort, if it's successful, will restore degraded lands and capture an additional 20 billion hectares, 20 billion tons of carbon dioxide annually, while simultaneously improving livelihoods and caring for the land. Next slide. 20 billion tons doesn't seem like an awful lot of carbon, but few people realize, including restoration professionals, that positive regenerative land use change is already occurring of an order of 10 billion tons of carbon dioxide per year, as shown in the orange bar on this graph, according to the renowned Global Carbon Budget, which is published annually. This means that a lot of good work is already in progress successfully and can be accelerated. The 10.6 billion tons of more carbon removals that are being done by managed ecosystems is greater than what is being accumulated and absorbed by natural terrestrial ecosystems or by the oceans. So that is quite remarkable, and it speaks to what is possible when we further ramp up land restoration in the coming years. Now, this looks promising, but there is a big looming problem: global heating acceleration. Next slide, please. There are serious warming signs on the horizon. There are now indications that the global terrestrial carbon sink is weakening due to global heating, and this could endanger much of the good restoration work that is being done around the globe. Unless we can stop the incessant and accelerating temperature rise, much of what we are accomplishing together may be reversed in the coming years. Next slide. And indeed, global heating is accelerating. Temperatures are now rising more than twice as fast as they were even a decade ago. Carbon dioxide and methane emissions continue to rise each year, and the 30th Climate Change Convention, which just wrapped up in Brazil a few days ago, but had indiscernible progress in controlling greenhouse gas emissions. Next slide. As a result, the Earth's energy imbalance continues to widen at an alarming rate. The Earth is now absorbing much more heat than it is releasing back to space. And the troubling thing is that this is no longer mainly due to carbon emissions alone. Next slide. That's because the planet is also darkening. Its overall albedo is declining. This is because at these elevated temperatures, the Earth's cloud cover, which is the predominant way that the planet reflects sunlight back into space, is markedly declining. And that decline in cloud cover appears to be accelerating also. We must now seriously consider the need to increase the reflectivity of the Earth, in addition to reducing emissions and ramping up carbon removals from the atmosphere, or else temperatures will continue to accelerate. We must reduce, remove, and reflect. Next slide. And if we don't jack up sunlight reflection, we will be exceeding the 2 degrees by 2037, a decade from now, 2.5 degrees by 2048, and we will break through the 3-degree limit by 2060. We're just about run out of time to keep temperatures anywhere near safe levels. Next slide. On top of this, we are being warned by hundreds of scientists that there are some 15 major Earth system tipping points that are now in great danger of being triggered irreversibly. These tipping points are connected to each other, and they could devolve into a cascade of triggered tipping points during the coming decade or two, since many of them may be activated within the temperature range of 1.5 to 2 degrees, which is exactly where we are right now. I draw your attention specifically to the tipping point called the Atlantic circulation that transports a massive amount of heat from the tropics up into Europe and is responsible for the relatively mild climate of Western and Northern Europe. Next slide. Stefan Ramsdorf and James Hansen are two of the most prominent scientists who've been studying the slowdown of the Atlantic current circulation. They loudly warn us that the Atlantic Ocean circulation may soon collapse, perhaps by 2050. This would be the most dangerous tipping point for the European climate and globally. It may happen as early as 2050, and this would result in a Siberian climate descending upon Northern Europe, an increase in severe storms, increased heat and drought stress in Southern Europe, a shift in the tropical monsoons affecting billions of people in the global south, and major changes in agriculture with profound consequences for European and global food security. The key questions for agroforesters and foresters are: how do we prepare for such a potentially disastrous situation? Could agroforestry be adapted to it? And could it be a stabilizer for European agriculture? No one knows the answers to these questions currently, but they urgently need to be on the table as European agroforesters and global agroforesters look ahead in the next 2 or 3 decades. We do know that we can keep temperatures below, only if we can keep temperatures below 1 degree, can we possibly reverse the decline in the Atlantic circulation and retain a relatively stable climate in Europe and in the tropics. Next slide. But that is now virtually impossible unless we add one more tool to the toolbox. In addition to emissions reduction and greenhouse gas removals from the atmosphere, we would need to deploy climate cooling interventions as the third and last available tool in the toolbox. Next slide. Now, David Fay, the co-chair of the Scientific Assessment Panel of the Montreal Protocol, has noted that to bring global temperatures down quickly, the only button we can push that we know about is solar climate intervention. That is, sunlight reflection methods. Next slide. The cheapest and most practical way to do this is to develop a thin veil of aerosol particles in the upper atmosphere that may reflect a very modest amount of incoming sunlight back into space and at least partially restore Earth's energy balance. We know this will work effectively because major volcanic eruptions have done this many times in the past. When Mount Pinatubo erupted in the Philippines, where I'm now located, in 1992, it lofted 20 million tons of aerosol particles into the stratosphere. Next slide. Lo and behold, the temperature of the Earth declined by about 1/2 degree Celsius during the next 2 years, 1992-93. And it did this without any significant negative effects being detected. So we know that it works. And there is now a lot of research around the world on how this effect can be replicated with a small fleet of airplanes that could spray aerosols at high elevations, just like the volcanoes do, and reverse this process of global heating due to the lack of reflectivity of our planet. Next slide. The Healthy Planet Action Coalition, which I currently chair, is urging the world community to come together to carry out an equitable, science-based plan of action to include directly cooling the climate through sunlight reflection and ecosystem restoration and other safe and effective means, while accelerating emissions reduction, which has not been going very well, and deploying large-scale removal of atmospheric carbon dioxide and other greenhouse gases, which is just in its early stages. Doing these three things to reduce the average temperature increase to well below 1 degree in the coming decades. That's a very tall order, but it's increasingly being recognized as essential to cope with our heating emergency and to restore a safe climate for our children and grandchildren. The painful reality is that the 1.5 Paris target is now dead. The UN Secretary General even said so last week. The 2 degree Celsius target is also nearly dead now. We are on track to surpass it merely in another decade. COP30 just wrapped up in Brazil a few days ago, and there was little indication that it will have had any significant effect on emissions reduction or the global temperature acceleration. The petrostates once again blocked any plan to transition away from fossil fuels. Of course, we can continue to pray for a miracle in emissions reduction in the coming decade, or we can get serious about applying purposeful climate cooling methods to forestall devastating effects of climate change, particularly on the most vulnerable people and particularly in the global South. Next slide. So, my recommendations for the agroforestry and forestry community. First of all, I urge you to greatly accelerate your research and development going forward on 3 things: on the risks of uncontrolled heating acceleration on future agroforestry and forestry systems. Second, on how agroforestry and forestry can be made more resilient to accelerating global heating in the future. And third, on how agroforestry and forestry would be positively benefited or negatively affected if direct cooling interventions were deployed to bring down global temperatures. I urge you also to speak out vigorously on the serious risks of accelerated global heating to European and global agriculture, agroforestry, and forestry, with particular risks to food security and impacts on vulnerable populations. It will be interesting to interact with the upcoming speakers in the program about how these threats may impinge upon the future of agroforestry in countries like Portugal, Italy, and Kenya that are on the program. Next slide. So as I conclude, for more background on the topics I've covered today, you may look into these 3 websites. And we've just convened a major global online conference on the heating emergency, focusing on the question, what's the plan? For indeed, we need a new, more comprehensive plan that's based on the rapidly evolving science on the temperature acceleration and what we've got to do about it. If you'd like to learn more and get engaged with us or follow up, do feel free to contact me by email. I look forward to interacting with you. Thank you for listening, and I look forward to the Q&A discussion.
Thank you very much, Dr. Garrity. That is I'd like to say a wonderful way of starting. It's a very concerning way of launching our webinar today that really goes to the heart of what we need to discuss, what we need to do. Before we go on to next presentation, I'll just see, does anyone have a question that they would like to pose to Dr. Garrity? We will have a little bit of time towards at the end. Okay, good. Thank you. Then thank you very much, Dr. Garrity. Dr. Agnoletti, I hope that you've got some good news for us and some actions that we can start working on. Our next speaker is Dr. Mauro Agnoletti. Dr. Agnoletti holds the UNESCO Agricultural Heritage Landscapes Chair at the University of Florence in Italy. I imagine his office is a little bit down the hall from where our Antonio is sitting at the moment. Dr. Agnoletti has also been very active in a variety of international forums, the International Association of Landscape Ecology, the European Society for Environment History, a scientific advisory group from the FAO program on agricultural heritage. Dr. Garrity has mentioned the likelihood of changes with the Atlantic circulation happening and hitting hard in Europe. So I think that Dr. Agnoletti, I'm hoping that you will be able to have some sort of response to that and being able to put that into a little bit of context. But I'd also just like to, as this is an IUFRO event, I'd like to signal that Dr. Agnoletti has also, last year at the IUFRO World Conference, he received a Distinguished Service Award by IUFRO for all of the work that he has done, not just for IUFRO, but on understanding the historical impacts of ecosystems and trees over time. So Dr. Agnoletti, over to you, please. Thank you very much.
I hope you're listening. Yeah?
Yes, we can hear you. Please go ahead.
Okay. So as I was saying, I could not listen to your presentation. However, thank you for this invitation. And I want also to congratulate with Stephen Wyatt for taking over the lead for this research group that, as you probably already said, I've been chairing for several years. So I'm glad to see there is a new blood and a new spirit in the work we are doing, and I'm very happy. I see a great future for it. Also because what we are dealing with, I think, is very important also for what we just heard. And what I'm trying to present here is a perspective on the global important agricultural heritage system program of the FAO and the Italian Register of Historical Rural Landscape. So basically, we have been and we are still researching a lot on this topic. We had a huge project of some million euros from our government, basically for training and students and officers to manage this traditional system, but also to identify and locate this system across the world. So in the sense that, as you know, this agroforestry system has been developed through some millennium of history and the result of the adaptation of culture to different and changing, I would say, environmental condition. So the idea of studying this system is just to learn some lectures on how to adapt if not also to mitigate climate change. And the first thing to do is understand this system. And there are organizations, particularly the FAO, dealing with identification and conservation, not only, let's say, static conservation, but in order to survive this system, they also need to have to propose an economic return for the farmers, because farmers are living out of this agroforestry system. So one problem is to identify them, to support them, to study them. The other thing is to find a way for farmers to continue to use this system also for surviving, which is a very important and crucial thing for these farmers. And so basically, identifying the system, we can go for identify the system, we can go through two main UN organizations. One is the UNESCO, basically the World Heritage List that in 1992 opened up the door to cultural landscape, and particularly to agricultural landscape. But perhaps the most interesting program dealing with this is the FAO GS, Global Important Agricultural Heritage System, that started in 2002, has a research program, but in 2015 became a regular program of the FAO. And this speaks about the success of this approach. I've been chairing the scientific advisory group of this program for 5 years. And so the interesting point about GS is that the criteria for designating the site refer to very important element for understanding this system, which is first the contribution to food and livelihood security. You know that today hunger is still a big problem, which speaks about the fact that industrial agriculture did not succeed in providing food for the entire world population, but also for food security, which is another big problem. Many countries, many populations do not have access to food and not have a food security. And it's interesting to know that even in Europe there are countries that are not fully food secure. Then there's the agrobiodiversity, which is, of course, is very much related to this traditional system, because there's a biodiversity that is related to the activity of the farmers, differently from natural system. In this system, at the center of biodiversity is the farmer. And so with these traditional practices and, of course, good practices that can contribute to biodiversity. We also have a European project based on this, which is related only to Europe. But this topic is strictly connected to the third criteria of the FAO program, which is traditional knowledge. All these systems are related to traditional knowledge. In other words, you do not find textbook on where to learn how to manage this system. And I have to say that even for us in Florence, we have organized a master degree for 3 years teaching this thing to the students coming from 4 continents. One of the first problems we had to encounter is that we as teachers did not have really a complete set of textbook to give to the students and informing them on how to manage the system. So it was a very interesting and challenging aspect, where I have to say that the contribution of the students coming from these countries of the south of the world is fundamental also to discuss and to understand this system. Then the culture, value system, the social organization is another crucial element in this traditional system. The cultural identity is still very strong, as well as the social organization, which is part of the reason why this system are still surviving, as they are not very much considered by the national governments or even by other organizations that can that related to economic aspect. And of course, this system also produce a beautiful landscape. That's another element. They may be seen as simply an aesthetic element, but if you want to make this traditional system survive, today we can then take advantage of all the values included. And to make the long story short, to place a traditional food on the market today cannot be done considering what are the trends of global economy, which means high production and low price in order to have a competitive cost. You have to add other values to it. And the landscape is presenting the advantage of being an added value that cannot be replicated by a competitor. So visiting these places, you discover something that cannot be found a stack of the supermarket, and it is transferring to you an emotional feeling that create a close connection with these places. And in this way, you are not only spending your time in this place, but you can also invited to buy food that otherwise you would not be able to find in the supermarket next to your home. So the idea of the FAO globally important agricultural system is based on this magic word, which is system. So in this slide, you see this Zhejiang Mulberry Dike fish pond system in China. So these are ponds, on the banks of these ponds there are the mulberry trees. So the idea of system relate to the fact that mulberry leaves are fed to beneficial worms, the silkworms. Worm feces is fed to fish. Mud in the pond, including fish feces, become fertilizer for the mulberry tree. And 4 types of fish farmed and the same system, silk and nuts are produced. So this is a self-sufficient system with a very reduced external energy inputs, which is basically the work of the man. And this gives an idea not only of the adaptation to a difficult environmental condition. In this case, we would see the lack of soil to cultivate the land, but the fact that this system are surviving for many centuries, sometimes 1,000 years, explain the importance of understanding them, because from this kind of system we can really have lecture and we can really learn on how to survive in certain area of the world. And here's another system, the Salak agroforestry system in Karangasem in Bali, Indonesia. In this case, they look more like a forest, but again, the production of this fruit is done according to traditional technique that may exploit areas where otherwise no other forms of agriculture could be developed. So, in a way, this is another system that has been continuing through the centuries and very effective in proposing adaptation. And here we are in Iran, where they're producing figs according to a system that is creating some ponds around a single fig tree where to maintain the water. As you know, in the previous slide, you've seen an excess of water, but in many countries there is a shortage of water. The problem of maintaining the water will be also, as we heard for the previous presentation, one of the main problems in the future for many countries. So these systems are very precious in terms of the lesson that we can learn. And so understanding them is one of the things that we can do through research. But what FAO is doing is to make agreements with the local government in order to maintain them. And as you all know, the desert is also presenting fantastic way of adapting to difficult environmental conditions. Oasis, and in this case, the good oasis system in Algeria, from my perspective, looks like miracles, because you develop an agriculture which is very rich in terms of many different cultivation from sand, which to a European like me, for the first time I visited there, would look like an impossible place to develop agriculture. And also in the African continent, there are fantastic examples of this. Here's the argan cultivation. I don't know how many of you have been visiting the Atlas Mountain at the latitude of Agadir, where you have this system that are multifunctional system. The argan tree is a spectacular tree that is able to send the roots even 50 meters down in the soil to look for water and to survive. When there is no water, the plants looks dry. You see all these forests looking as they are dead. There is no life in it. But after a rain, you can pass like a week, 10 days, and they turn green again because the leaves are opening and they are again transpirating, allowing the tree to survive. And as you see on the top left, there is a goat climbing this tree, and the goat is eating the nuts. And when they release the faces, the farmers, and mainly women, collect these nuts and produce an oil both for edible purposes and for cosmetics. And this is really an interesting system because it's keeping together pastoralism, so livestock raising, and also a production made from these nuts, and is really another interesting example of adaptation. And another spectacular, sorry if I repeat this word, but to me the extraordinary example of adaptation, which is very much related to the disaster that we are so often discussing for the future, is the Lanzarote Island. As probably some of you knows, in Lanzarote Island, the Canary Island, outside the coast of Africa, there is a volcano here that in the 16th century erupted, destroying all the agriculture existing in the island. So the farmers have to invent a way to cultivate this area on the lava beds. So what they did, they dug these holes, as you see, this depression in the soil, creating a microclimate which would take advantage for the heat of the sun, which is hitting very much the lava beds, creating a favorable climate for producing and planting different kinds of trees. Mostly these are orange trees, fig trees, but there are also many vines growing in this area. Those stone walls that you see are oriented towards the wind coming from the sea, which is very dangerous for the trees. So these are protecting this. And you may think that this is a difficult way of surviving, but as a matter of fact, the economy in the island is pretty well developed. And so they find a way of being successful in this attempt to react to a real disaster. Other system dealing with water, these are the Chinampa agricultural system of Mexico City. So these are as a way of producing plots of land that are more or less floating on the water, and so created island that on which you can cultivate. And this is a kind of agriculture that allows 5 crops per year. So the interesting things about this traditional agroforestry system, they can be very productive. We often think of this form of agriculture as an unproductive, of a low production. As a matter of fact, they're the product of a very fine and deep thinking, considering the relation between environmental feature of the areas where the local population live and their needs. We've been trying with our team, led by Antonio Santoro, to study the geosite and understand the role of forest and agroforestry system and in these sites. And we noticed that they play a fundamental role both for hydrological production and water regulation, for landscape, for timber and fuel, food byproducts, for biodiversity. So there is really a whole world to discover and still to be analyzed and understood, because there are really many lessons that we can learn. Another thing to which they are related is that these systems are normally placed inside very complex landscape mosaic with a high number of small patches. We developed a comparative study concerning the Viñales Valley in Cuba, the valley of Telouet in Morocco, more or less of the latitude of Marrakesh, and also in the Etria Valley in Italy, in Puglia. And we noticed that although we are in really different socioeconomic condition, in very different political condition and environmental condition. What they have in common is that these lamps are organized in very small patches that create this very complex mosaic with a dense, high number of trees that are cultivated, producing many different crops. And once again, the fact that they survive for so many centuries is really something that we have to understand. And for concerning Italy, where of course we are based and we had many opportunities, not only to study them, but as I will show you, to transfer this into policies at governmental level. Here we have system that exists since Etruscan times, which is the population existing in Italy before the Romans, so more or less 8th century before Christ. What you see, these are systems that see the presence of vines trained to poplar trees, about 12 or 15 meters high. And you see in the bottom myself next to a poplar tree with the stairs that are used to harvest the vines. The interesting thing of this system is that they're still there, fine. They're producing wine. They're allowing several cultivation on the same plots of land. And as in the previous cases, Etruscan had a very deep understanding of environmental conditions because in those times they were mostly cultivating the plains. The plains in Italy were very humid. There were many swamps, and so the vines and don't like humidity. So the farmers were sending the vines very up on the tree, closer to the sun, in order to take advantage of the heat and so allow the grapes to ripen. And this poplar tree also were pollarded to allow them to sustain these vines. And this is also a beautiful landscape, as you see, and they're still producing the wine. It's a very special wine, and the fact that these people is surviving over there with a very low production per hectare, but a very high quality product is again a lesson to be learned. And all this system, of course, are related to this knowledge on how to also to tie the vines, as you see in this picture of this farmer, to these trees. And you see these trees are still there, although in some area there are a minority of crops that are managed in this way. And but we still maintain, for instance, the knowledge on how to produce from a mulberry tree, in this case, not wood, but leaves, which means to adapt the tree to your needs. I mean, from a tree you can, produce what is needed. In this case, are leaves to feed the worms for the silk production, but also for the cattle to feed them, because this system were produced when there was a shortage of fodder for the animals. And even in forestry, there are incredible numbers of different ways to manage a single tree. In this case, you see on the left shredding, which was used to produce branches. On the left side, you see different forms of adaptation of trees to grazing. In the lower corner, left corner, you will see that there is a tree on the bottom and smaller bushes on the right. Well, this is the same species, is beech, Fagus sylvatica, which for many students, when I show them in our forestry courses, they never guess that these are the same species, because normally we think of beech and fagus as a tall tree that it's managed according to achieving that form that we can easily recognize. Well, the shepherds were adapting these beeches in order to produce fodder in this case. And this is a photo of the surrounding of Florence that you show how many trees there were in the countryside, how this agroforestry system were so important. And this is what happened with the intensification of agriculture. You see on the left side a photo of 1954. On the right side, a photo of 2020, you see the reduction of trees in the countryside due to the intensification of agriculture. Now, something to say concerning global warming and what we are going to witness in the future, that what those who will be more in trouble are intensive cultivation that are in need of water, chemical fertilizer, machinery, and so on, because they have more difficulties, in my view, to adapt to what we are going to face in order to maintain this very high level of production. And while instead in traditional system, you are not looking at very high production, you are more likely to use this system to survive for the local condition. This is a typical example of olive trees. The olive tree is an arid crops, is developed in the Mediterranean to survive in very arid region. So the problem are for those intensive olive orchard that requires water. And while you see here in this photo, especially on the left, these olive trees on a mountain slope in the center of Italy. People here broke the stone with the axe in order to produce a very small place where to plant the olive orchard, which is an incredible amount of work, of course, but it has also to able to produce this beautiful landscape that you see. And in Italy, we have been studying with the National Register, investigating 126 areas across the country, where we study the historical origin. We're monitoring many different features, the distribution, north, center, south, and also the altitude. I don't want to go through. Stephen, tell me how I am with the time.
It's just about to come in and interrupt you there, Dr. Agnelletti. I'm afraid I'll ask you to go straight on to a conclusion.
Okay,
please.
I just finished with the last slides. Is okay?
Yes, please.
You went to the last slide. Okay, this is the National Register of Historical Landscape Agricultural Practice and Traditional Knowledge. The government is developing this initiative in order to locate and maintain this system. Let me finish with the fact that the farmers living in this area receive today 800 million euros from the National Agriculture Policy to maintain this system, because we believe that in some areas, especially in marginal area, this is the only way of developing agriculture. Intensive agriculture did not succeed in this area, so the government thought, and we are the one who established this national register, that it's good to maintain this system and give them subsidies with the national agriculture policies. Thank you for your attention.
Thank you very much, Dr. Agnelletti. After listening to your presentation, I feel much happier with our prospects than I'm afraid I did after listening to Dr. Garritti's presentation. You've laid out some options for us and stressed the fact, the hope, but also the work that we need to do. So thank you very much. I'll move straight on now to our next speaker, who's coming to us from Évora in Portugal. Dr. Teresa Pinto Correia, as a geographer and a landscape ecologist at Évora University. She's director of the Change Institute for Global Change and Sustainability, which is bringing together over 300 researchers. Most of her work is with Mediterranean agriculture and agroforestry systems. And what I particularly liked, you're working on that interface between science, practice, and policy. Now, I'm just going to pick up the practice there. Often we talk about the science policy interface, but I'm impressed with the link into practice there, which I think goes to some of what Dr. Agnelletti was just talking to us about. Dr. Correia is also a vice chair of the European Community's Soil Mission Board. So, Dr. Correia, over to you, Dr. Pinto Correia, sorry, over to you, please. Thank you very much.
Thank you very much. Thank you, Stefan, for your presentation. Thanks, everyone, for listening. Thanks to IUFRO, to this working group, for inviting me. I'm very pleased to be here. And I will share my presentation. I hope it will go well. It's here. Hopefully you can see it now.
Yes, we've come up now. We've still just got the overall screen, not the actual presentation screen.
It's okay now?
That's good. Thank you very much.
Okay. So I'm going to talk about this example of a system with lots of trees. So it's what we call a agro-silvopastoral system, but currently it's much more silvopastoral than agro, but originally it had also cultivation in rotation with grazing. And I suggested this title because the system is still there. There's a lot of qualities and a lot of very important, I would say, assets in relation to what we have been discussing here, but it's strongly under pressure by different reasons I'm going to talk about. So it's the work of myself, but together with a large team. We are many in what we call the LabScape team, Mediterranean Landscape Systems Lab. So we work always with this landscape approach. And many of us work with this system, the Montado system. It's called Montado. There's the same system in Spain. It's the Tejesa. And you have already presented me, so we are part of these organizations. But we have somehow developed our experience starting with research, with analytical tools and analytical approach, and more stepped into contributing to policy and contributing to practice. But I'm going to talk to you about the system and about what is ongoing with the system. So it's beautiful. As you see, we have cork and holm oaks. And here, yesterday I was thinking when I went to bed, oh, I missed the cattle or the livestock under the trees, because the system, it's not only trees and beautiful grass underneath. The system exists because there's grazing underneath. So it's in Europe, we have a lot of this agroforestry. They are different. Some of them are in this way, extensive combined grazing with trees. Some others are more intensive, but you can see they are very important in Southern Europe. And there, where we have what this map in the middle shows, is the pressure or the vulnerability to climate change. So you can see almost a parallel. The areas where we have these systems, it's also the areas which are most subject to strong impacts of climate change. And we are facing them already now, with decreases in precipitation and increase in average temperature and in peaks, in extreme temperatures. So what I'm showing here is the Portugal of Spain and the map of Spain and Portugal, and you see the area of this system, how big it is, even maybe a bit broader, but here you have the precise location. So this is the map of the distribution of this system, with the green dots showing the cork dominance, and the red dots showing the holm oak, which can cope with a bit more dryness climate. So we have in the interior, we have the holm oak, in the littoral or closer to the littoral, and in the higher areas, we have the cork oak, which requires a bit more of humidity. And we have also, and I think it's very important to remember why this system, we say it's resilient, because it has really been adapted to these very particular conditions of the Mediterranean climate, which have the decrease in precipitation where we have the highest temperature. So that's the opposite, sorry, the temperature here in summer, the high temperature with decrease in precipitation. So very dry and long summers with very high temperatures. So the season where we have growth is the spring and a little bit in autumn. But we have a very huge interannual fluctuation in precipitation. So it is like this. It's not only the total precipitation that changes, but when does it start? It can start in September, it can start in November. We can have a very humid autumn or a very humid spring, or both. So it's very unpredictable. The only thing which is more predictable is that summer is dry and hot. And we have also poor soils in this region. So the management, in order to maintain soil quality, needs to be very careful. So we are subject to these conditions, and that means that a system which has developed under this condition is naturally a system which is resilient and can cope with changes up to a certain, within a certain interval, we may say. So what is the particularity of the system? So we have grazing underneath the trees. It's really the combination of crop, of the animals and the forest. So we have the different types of agroforestry, but ours is this one where the most important thing is the combination between the tree cover and the grazing underneath. It's very complex because its value relies also in the fact that there are not only grazing, but also shrub areas. There's areas with more dense trees and areas with less dense trees. There's areas where you have a combination of livestock, or you have a more specialized livestock, but the livestock can easily live together with wild animals like wild boars and other types of game. So it's very interesting from the point of view of biodiversity, and it's also classified very often as a high nature value farming system. But of course, it is complex to manage. So we have meat story here. There's a typo. It's meat and cork. That's the main production. But currently there's a big attention to this system because it is capable of storing high quantities of CO2. And we have measurements. So we have been doing an extensive work with measuring, taking soil samplings and measuring, evaluating the soil in the lab and evaluating the trees. So we have an average of 60 tons per hectare of carbon, which is stored combining the soil and the trees, but it can go up to much more if there is a high density of trees combined, because then, but I will explain that later, then it will also benefit the soil. But it's a biodiversity hotspot. So it's classified as high nature value farming system according to the Joint Research Center of the European Union. And we have observed that in areas where we have maintained the system, there's less impact of these desertification trends, which are related with climate change coming from Northern Africa. And it's also very much demanded for recreation, for its aesthetical value, as I've said before. So what is the particularity of this system? That it's really difficult to classify, difficult to interpret when we look at it when you try to map it, because the tree density can vary a lot, can be very changing within the same farm property. We can have areas with very dense tree cover, medium or low tree cover. But when you have this very low tree cover, what is happening is that the system is in decay or is being reduced, because the way that the trees grow, it's not by planting, it's by natural regeneration. So the grazing intensity needs to be adapted to the capacity of the system to renew the tree cover. So when we have intensified farming, what happens is that we move from this high tree density to a medium. And then if we have this amount of trees, then what is happening is that the young trees are much more difficulty to grow, and they will maybe not be able to grow, so the system will start into a process of collapse. It's not obligatory that it is this way. If we have a small patch in the middle of our more dense areas, there's no problem. If the dominance becomes the low tree density, then we have a problem. And that's what we have been observing. So it's a kind of unseen decay process, because we have a decrease in the trees. The pastures lose productivity, so it's less interesting as a grazing area. Farmers have to buy more fodder from outside instead of being able to keep the animals outside eating from what the system provides. So it becomes economically less viable to have a farm in this way. It's very large farms, so they can cope with also variations in climate and experimenting a bit. But it's when you start having less trees and the soil starts being less fertile and producing less, normally what you continue is intensifying, having more animals to have some income from the common agricultural policy, and there's really a circle of decay. What we have observed, so we start with 1 million hectares, well, a bit more than 1 million hectares, that's what we have now, 1 million hectares in Portugal and 3 million in Spain of this system. But we have been losing, until 2006, 5,000 hectares per year measured. So we have measured this with spatial analysis. And now, since 2004, we have measured again, and we have an average of 3,000 hectares per year. So it has reduced a bit, but we can also say a lot of the more fragile areas have been lost already. So it's constantly decreasing. However, there are measures and a lot of policy instruments to keep the system. What are the drivers of such losses? One may think that it's by replacement and cut. No, it's not, because the trees are protected by law. They cannot be taken out for something else. It happens that trees are cut because there's a building project, a touristical project, but it's still very, very minor in relation to the total area. There's a bit of replacement of areas which were formerly montado areas by new plantations of wine or olive or almond, because we have much more irrigated facilities in the last 20 years. And there's been a bit of this change, but it's like 3% of the patches which have changed in this way. There's been a bit of fire, but affecting very little of the system, because the system is open. And because it's open and the undercover is kept clean, We have a lot of fires in Portugal and a big problem as many other Mediterranean countries in Europe, but it's more in the center of the country in the north where we have intensive and monocultural forests, not here. So this is not the problem. The problem is, as I told you just before, we have this tree cover in 2004, and then when we go there, 14 years later, there's all these trees have disappeared. So all the red dots are trees who have disappeared and no new trees appear because this is already, the density is too low. It's very difficult for the young trees to come up. So the whole area, if you remember the map I showed in the beginning, we have this whole southern part of the country covered, or where this system is dominant, but overall we have registered this decay. And what the most important decay, so this is a map showing exactly what is happening, patch by patch. We have loss of areas, so they simply disappear. We have areas which were before montado, they get perforated. It means that they have areas in the middle which are now empty of trees, so it's an opening. And we have areas which have been fragmented, so they are still there, but in the middle there's something else, so they are not connected. So it's never, or very rarely, it is because something radical has happened from one moment to the other. It's much more this progressive deaths, which you only register with a time interval of at least 10 years. Then you see really that it has disappeared and something has happened. So the pressure is very good, very strong. Why this happens, we have been studying the reasons behind the decay, and a lot of it has to do, statistically, it is clear that when you increase the grazing intensity, if you go above a certain level of grazing, then if you are not taking care of the soil and of your pasture, which is normally the case, then the montado starts in decay. So there's a connection between the process of decay and the process of agricultural intensification by intensification in the production of cattle. Why the production of cattle has been cattle or livestock? It has been increasing. It has been increasing because in Portugal we still have coupled payments from the Common Agricultural Policy, which are related with the number of animals you have. So the higher the number, the more you get. And because of this, it's very tempting for farmers, especially if they are in an economic difficult time, to have more animals in the system because they will receive a higher payment. So we have up to 70% of the income depending on subsidies on these types of farms. And what happens when you decrease the number of trees is that obviously the temperature at the soil level is increasing. And because the temperature at soil level is increasing, the soil cover is less complex and grows less. So you'll have more and more of the soil which is uncovered, and more these temperatures are high. So that means that in the middle of the trees, where you have the trees, you have the shadow, you have a bit better conditions, but you have larger areas where we have excessive radiation and air and soil temperature. So the trees here to grow, they will have difficulties, but also for the animal welfare. We have temperatures here in the summer up to 40. The peaks are above 40, but from 35 to 40, that's a normal temperature in summertime for many hours of the day. So it has an impact on the probability of the tree survival, and it has an impact on livestock welfare. And what we have been measuring, which is very recent, we have not, everything else we have published, these we have not published yet, because we have been measuring the carbon stocks. And what we are showing here is this is the distribution of a typical stand. And when the decay starts, that's what we have on this side is the expected decrease in trees and in tree size. So the colors show different tree sizes after 20 years. And when the trees, so the curve is shown here. Oh, sorry. The curve is shown here. And then also the decrease in carbon sequestration, carbon stock and carbon sequestration. It's very strong. That means that when you have the trees, it's not only the tree which has sequesters carbon or has carbon in itself, is also the soil which has much more because it's under the tree. So the soils are because the soils are so fragile, the difference between being below the canopy or not is very strong. So you have much better conditions from these starting fragile conditions, much better under the trees than outside the trees. So it has an impact not only on the productivity of the system, but also on these new assets, which we would like this system to be recognized for, which is climate, the impact of climate and being able to contribute with carbon sequestration. So what we have been doing more and more is that we have trying to understand why farmers take these decisions, while at the same time they're extremely concerned by their system. It's a family heritage. It's not really considered as a production factor. Your land is considered as something you have as family heritage. You would like to pass it on to your children in the same conditions as you received, but they don't do. They are really intensifying, not all of them, but a large part of them. And what we see is that the system is very complex. It was based on very intensive labor on a lot of employees working in a farm until the 70s. So there was a more feudal, almost, you cannot say feudal, but almost feudal structure until 50 years ago. And this lack of labor and mechanization of work should have led to another way of managing and other concerns, which didn't happen. So farmers tried to have the same attitude to their farm without being subject to any advisor or knowledge transfer about how could we do now. So there's a kind of lack of capacity to innovate as long as farm structure has been changing, labor has been changing, mechanization has been changing, and then also the subsidies and the market and everything. So nobody has really guided these farmers and can you maintain the system. They are normally well educated or highly educated. They are very large farms, but still they are pushed to this specialization and simplification because it's the dominant paradigm. It's the regime discourse is that you have to earn money, you have to produce livestock, you have to sell to this new market of livestock, which is absorbing the livestock from the Eastern Mediterranean, from Northern Africa. So we have been continuing producing more livestock, much more than it used to be produced in this system. What we have been doing, and I'm very short time, but what happens with the research team working with the system along years is that we started working with farmers, starting discussing with them, interviewing them, and we understand that in the beginning we were just saying, I mean, if you want to organize yourself to create an association which takes care of the farming or ask for other policy tools, you have to do it yourself. But then we realized they are not doing it themselves. They are not able to of these organizations. So we stepped in this process. And in 2016, we launched what we call the Tertúlias do Montado. So it's a regular meeting arena where we discuss between stakeholders, farmers, policymakers, and researchers. It's a project-free platform, so there's no project financing. It's running with different types of support. And we create we create a kind of a network with farmers where they interchange. There's a WhatsApp group. They change opinions. We visit farms. We do sessions in the room, but we also visit farms. And together, but still led by research, we have proposed to the Ministry of Agriculture a new form of agro-environmental payment. So we have a pilot of this, what is called result-based agro-environmental payments for the Montado system, with sites in two Natura 2000 areas and contracts with 184 farmers. So this is something which is running. We are managing this measure for the Ministry of Agriculture, what is new. So this is why we say we stepped out of the research sphere to first work with practice and now work also with policy. And farmers, somehow they have not directly asked, but there's been a pressure from this farming community that someone needs to do something, and that's what we are trying to do. And in 2024, we have many projects where we collaborate with the farmers in different ways, but they are time limited. We launched this living lab, the Montado Living Lab, which is concentrated on soil regeneration because soil is a big problem. Living labs is a concept which has now been very much discussed and proposed by the European Commission, and in the soil mission, it's one of the missions where we talk about living labs. This living lab was inspired in the model of the soil mission. We are certified by the European Network of Living Labs. And we hope that this may help to produce solutions together with the farmers, which then they can apply. So the idea of the living labs is to do research together with those who are the end users and work with them for implementing these measures. So we are looking a lot at the soil as a way to get higher productivity in the system, but also together with the soil, how do you protect the trees, how you facilitate regeneration to try to see if we can revert this trend and get more confidence to farmers that they have someone to discuss with. And that's what I have to say. I mean, we have many other projects and areas, but I would like more to ask to reply to your questions than to talk for a long time. I was asked to talk 15 minutes. Thank you very much.
Thank you very much, Dr. Pinto Correa. And we're continuing with the idea of giving us hope, but you very much laid out some of the challenges that exist there. And I did particularly enjoy your comment that intensifying agriculture agricultural production is not the solution to the problem. It is the problem. So thank you very much for that. I'll take one question for Dr. Pinto Correa, if there is. Does anyone have a question or a comment?
Can I have the question? Yeah.
Please go ahead.
Thank you. Yeah, thank you for the presentation, Dr. Teresa Pinto Correa. It is very interesting. I have learned a lot, Montado. You explained agro-environmental payment. I guess it is governmental policies and also the farmer engaged. Can you explain more? Have you ever similar program with payment for ecosystem service, or it is a new type of the payment system targeting agroforestry? And if it has a short history, then it is very welcome to hear. Thank you.
Okay, thank you very much for your question. I thought yesterday about talking more about this measure, but then I thought I didn't have the time. So I'm very happy you asked this because this is a measure within the European Common Agricultural Policy. So the European Common Agricultural Policy establishes somehow the framework, and then the member states can decide on the details. So there was a kind of demand from the Commission, the European Commission, to say we need to have more of these result-based because they seem to be the way forward. We need to test them. Because in the result-based payments, what you pay the farmer is not for something he does, is not for protecting these or planting more trees, is by the result he gets. So you can plant as many trees as you want. If the trees are not surviving, then he will not get the payment. So it's incentivizing the farmer to have more initiative, to have more room for maneuver, and decide what they can do in their farm in order to reach certain objectives, which are environmental objectives. And we designed, that's why I said we did it with the farmers, because we designed the objectives together with a group of farmers, and we proposed it to the Ministry of Agriculture. So when the Commission started talking about result-based payments, we thought, well, this is an opportunity. We can maybe have one for the silvopastoral system, but it's totally new. There was no result-based payments in Portugal before, and there is no measure which is for the system. So that's why I think the collaboration here was very fertile, because I've been in Brussels in a meeting and heard about this, and then talked with some officials in Brussels whether we could propose, and they supported me very much. So then I discussed with my team, and then we discussed with the farmers. And we had a group of 10 farmers who said, okay, let's go for it. We will support you. So we discussed with them which should be the objectives, what should be the payment level. Well, the payment was more the administration. But then at the end, we proposed the whole program with the objectives, with the indicators, with the way to measure to the ministry. And finally, they accepted. So we have been negotiating with the ministry, and now we are managing these measures. So they started in 23, and until 27, we have been measuring in the field these indicators we have proposed. So the contract is with the ministry. We are paid by the ministry to administrate, so to be the technical responsible. So right now, we have a lot of results about how is it going, but in 2 years, we'll have much more results on what it led to at the end and whether we can continue. So this it's a minor policy within the very large and very important framework of the Common Agriculture Policy, but it's maybe a way forward. We think for the Montado to be also because it raises farmers' awareness about the need to take care of all the particularities of the system. So it's leading the farmers to think again more about the system and not just about livestock and subsidies. So hopefully it will lead to some change, if not in the system, at least in farmers' awareness.
Thank you very much.
But if you're interested, you're very welcome to send me an email. And then we have already a couple of papers on that. I can send you on the design of the system.
Thank you. Thanks a lot.
Thank you.
Thank you very much, Vison, for your question. I will move straight on now to our next speaker. Dr. Leila Nadelu is coming to us from Kenya, from Nairobi. Actually, I'm not sure if she's in Nairobi or not, because in fact, Dr. Nadeo works at the Kakamega Research Center, which is in Western Kenya, working for KEFRI, the Kenyan Forest Research Institute. She's been doing a lot of practical experience working with local communities on the nexus between forest conservation, indigenous knowledge, and sustainable livelihoods. She's going deep down into these ways of integrating perspectives on forest conservation, on management, and on natural resources center. And I think she did her PhD. No, I forget where you did your PhD, I'm afraid, Dr. Nadeo. But I pass it over to you now. Please go ahead.
To IUFRO, I'm facing some limitations with the internet, but I hope it shall be well. Okay. So I'm going to make okay.
With your presentation, or we can
is it on?
Florence. There we are. Good. Thank you.
Are you able to see it now?
Yes, we can. Oh, and I did forget to mention this is written conjointly with Dr. Chemeku Wakesa, who was also a research scientist with KEFRI and the regional director for KEFRI's Coastal and Eco-Region Research Program. So thank you. This presentation from both Dr. Wakesa and Dr. Nadelu. Sorry, Leila, over to you.
Okay, thank you all so much. I'm going to make this presentation, as mentioned, on behalf of our team, together with Dr. Wakesa, whom we've been working with on the issue of biocultural heritage territories as a sustainable model for agroforestry in Kenya's biodiversity hotspots, with a focus on Rabai cultural landscape. And as mentioned, we both work for Kenya Forestry Research Institute, and we look forward to hosting all of you during the IUFRO 2029 Congress. So just to introduce the Rabai Biocultural Heritage Territory. So it's an indigenous landscape which has a mosaic of land uses, different land uses, but most importantly is that these land uses are linked to indigenous knowledge systems that are mainly embedded in cultural traditions and practices. So it's a landscape that encompasses culture, biodiversity, conservation, and ecosystem protection. And then the main components is it's a very diverse ecosystem that has a sacred kaya forest. So sacred kaya forests are indigenous sacred forests of the Mijikenda community that resides along the coastal area of Kenya. So on top of that, the landscape has a rich agricultural farmlands with a variety of traditional crop varieties, and also some natural ecosystems like rivers, like some small mountains. And then I've mentioned that the system is very rich in culture, and this culture is anchored in a strong Kaya Elders Council that governs the conservation of the sacred Kaya forest. And just some context about the area. So the Rabai cultural landscape has an estimated population of about 97,000 people. The area covers about 21,000 hectares, and with an approximate household numbers of about 25,000 households. But even with all these richness, the Rabai cultural landscape faces some challenges. And one is the population pressure. It's located near an urban area, that is Mombasa city, that is rapidly urbanizing and impacting negatively on this ecosystem. Then there's a weak enforcement of conservation and conservation laws, as well as legislation. And that's mainly emanating from limited resources in terms of human personnel, as well as financial resources, equipment to enforce the laws. And then there's a weakening traditional governance system. And this is mainly as a result of youth out-migration, weakening traditional knowledge transmission systems as a result of modernity. Then we have the upcoming infrastructural development resulting from rapid urbanization of the area that is now extending from the city to outwards towards this particular cultural landscape. And then, as mentioned, there's the issue of erosion of traditional knowledge and culture because of the factors I've mentioned before. So in this landscape, that's the Rabai Biocultural Heritage Territory. And maybe just to mention something about biocultural heritage territories, they're actually landscapes that have really rich biodiversity that whose conservation is mainly embedded in cultural norm and practices, mainly enforced by indigenous people. So such is a situation in this particular landscape where we see very close and cyclic interaction between the people, their culture, the social governance structures that are enforced through traditional governance systems, the customary laws, spiritual values, the livelihood systems. In this case, it's mainly agricultural, that is crop farming and also some bit of pastoralism, and also the agroecological context. So all of these factors are interacting and supporting each other to come up with this holistic biocultural heritage territory. So what are the enabling factors for establishing this biocultural heritage territory for the case of Rabai? So the Rabai cultural landscape has a very strong cultural element that supports duality. So there is a strong Rabai cultural village that brings together really diverse villages and links traditional products to markets. These are products that are embedded in traditional and indigenous knowledge systems, referring to the basketry, the honey that is produced from the indigenous farming systems. We have some improved cooking stoves. We have some traditional grains and food that is also sold to the local markets. So this is supported by dualism, that is the acceptance and maintenance of both traditional knowledge systems as well as their modern belief systems, really coexisting well. And then we have a strong Kaya Elders Council. As I mentioned, the governance of the indigenous forests is mainly enforced by this strong Kaya Elders Council. This is further supported by a devolved governance system at the local level that supports these indigenous governance structures, and also the strategic location of the Kaya landscape in the Kenyan tourism circuit. Mombasa is one of the really popular tourist areas in Kenya. So these all of these factors actually contribute to position Rabai as a strong biocultural heritage territory. So there's a lot of cultural tourism taking place in the area as well. And then the ethnic composition of the area is largely homogeneous. So this supports common ecological stewardship practices that supports the rich biodiversity in the landscape. And then all these, the foundation of the biocultural heritage territory in Rabai is anchored on one indigenous concept, that is the Mudzini concept. So Mudzini is a local name for a village. So in this village context, the wild, the sacred, and the human are coexisting and supporting each other in a very harmonious way to ensure that the sacred is being conserved, the wild is being conserved, and also the human and domesticated plants and animals being conserved. So just some pictorials to appreciate. Right here at the middle, we have the Kaya landscape, that is the indigenous sacred forests in Rabai. And then down here, we have the traditional council of elders, who enforces roles regarding conservation and management of the kayas and the landscape in Rabai. And then further down, just appreciating some rich food from the landscape. And up there, we have one of the shrines where traditional rituals are conducted within the kaya forest as a part of mechanisms to protect the sacred kaya forest. And so again, we have a very strong cultural value system that is at the center of enhancing climate resilience, conservation of the kaya forests, agrobiodiversity conservation, and also conservation of the associated natural resources within the landscape. So the four main cultural values are those of solidarity, equilibrium, collectiveness, and reciprocity. That is what ensures that there is really harmony between the wild, the sacred, and the human and domesticated, and ensures that there is harmonious coexistence between all of these elements. Some rich food diversity that comprises of indigenous vegetables, wild fruit, cereals, and other crop varieties. So this is part of the landscape. And then we have a very rich flora diversity with a number of threatened species being conserved in this particular landscape through the rich cultural system. And also we are having a lot of agroforestry interventions in order to reduce exploitation pressure on the indigenous kaya forest. So here we see a sensitization meeting by members of the community. This is a training that actually aims at encouraging use of alternative cooking material as opposed to use of fuel wood. So here we have a briquette making session. It's a women-led process. So this ensures that we are reducing the pressure of exploitation in the indigenous forest by sustaining agroforestry systems within the homestead and also introducing the friendly energy alternatives. Then again, in this ecosystem, it's very rich in fauna as well. So we have a very rich diversity of butterflies, over 51 species of butterflies. So this plays a very critical role in sustaining agroforestry systems through enhancing pollination in farmlands and also enhancing cross-pollination between the crops on farms and the rich genetic resources. We have some wild relatives of crops within the sacred kaya forest. So we've also been promoting a lot of domestication. And because of the butterflies, we are seeing a lot of cross-pollination that is improving the genetic reserves of the crops within this landscape. And despite all of these, there are still challenges. We see here some animals hunted for food. In the middle, a lot of firewood collection, and at the far end, the right, we see some logging activities. So that shows that this system, as effective as it has been, it is still facing some challenges, especially coming from illegal human activities that needs to be addressed. So just some summary of the benefits that are derived from the Rabai Biocultural Heritage Territory. So the cultural values are used to conserve kaya forests and related biodiversity and agrobiodiversity. So I've mentioned that some of these trees and plants in the kayas are rich sources of food, herbal medicine, and also fruits that sustain the community, especially during periods of scarcity. Then we have agroforestry interventions that are embedded as part of integrated landscape management to enhance biodiversity conservation and also to improve livelihoods. And then the community has embraced domestication of key plant and tree species, mainly for food and nutrition security. And this has effectively contributed to the development of tree-based food production systems. And cultural values also are at the center of really promoting sustainable agroecological practices that are embedded in indigenous knowledge systems. And this has enhanced climate resilience and adaptation amongst the community, and also contributed to improved food and nutrition security. So in a nutshell, the Rabai Biocultural Heritage Territories multifaceted approach has really played a critical role in enhancing community resilience to climate change, enhancing sustainable agriculture in the community, hence improving food and nutrition security. It has contributed effectively in biodiversity conservation through maintaining that rich diversity of fauna and flora to support local economies and for conservation, and has effectively contributed to improving local livelihoods. So then, as I conclude, the Rabai Biocultural Heritage Territory, under the stewardship of this traditional governance system that is led by the Kaya Elders Council, has the potential to enhance conservation and sustainable use of biodiversity, and also to help the local community enhance their rights over protection of their land. And it has a capacity to preserve cultural practices, which all play a critical role in halting biodiversity loss. So then I mentioned that there are some challenges that need to be addressed despite the successes of this approach. But for us to achieve that, we need to strengthen the biocultural heritage territory model through community sensitization and awareness on the multiple benefits of this approach. We also need to ensure that communities take a center stage in collecting and generating information that can be used to develop timely interventions. And through this approach, we've really empowered the local community researchers so that they're able to drive the process and ensure that this approach becomes sustainable and community-led. So this needs to be enhanced further. Then the traditional governance structure should be reformed. As it is now, there are some few challenges that it may not be entirely inclusive. So we need to integrate women more, youth, because of the loss of transmission of the traditional knowledge, especially from elders to youth. So the inclusion is really key in sustaining this initiative. And we also need to strongly include village elders and community researchers so that it becomes a strong community-led process. So addressing poverty is critical for successful biocultural heritage territory establishment. And these can be achieved through a combination of both agroforestry interventions and biocultural products. So these are some of the products that the community has developed from locally available materials in the landscape. We have the coconut oil, which is very medicinal. We see some beekeeping here as a bio enterprise, and also the making of briquettes for sale, and also for local use to reduce degradation pressure on the indigenous kaya forests. So as I conclude, I'd mention that successful agroforestry model that is based on establishment of biocultural heritage territory should actually be anchored on supporting a community-led process, as I mentioned. That's very key to sustainability of this initiative. And also the creation of biocultural enterprises, such as the briquettes, the coconut oil, the beekeeping enterprise, could be supported further by also promoting revitalization of cultural identity. I mentioned that there is a lot of loss of traditional knowledge because of urbanization, youth out migration, weakening transmission of this knowledge from the elders to the youth. So this needs to be addressed, and also appropriate flexible funding coupled with the bottom-up facilitation through a community-led approach, and horizontal learning exchanges, that is between communities and communities, should actually be embraced more in order to support this process. So thank you so much for listening. That is the end of the presentation.
Thank you very much, Dr. Danilo. And that was a wonderful continuation of some of the same themes, and I think a very, very strong emphasis on the community and the cultural aspects and social. So thank you for that. I would actually, we are running over time. So I will actually take us straight on to the last speaker. And I have checked with technical support, and we can keep on going with our time period. So I'm hoping that some of you, most of you, will be able to stay on for a little bit extra time. And I will now pass us straight over to, to listen to our next speaker, who is Dr. Doris Mutta, again coming to us from Africa. Dr. Mutta, we've talked a lot about the problems, about the challenges, about how to respond to this, and so I'm very pleased that we have Dr. Mutta as our final speaker, because she's a program officer with the African Forest Forum. She's a forest scientist who's been working for more than 30 years across different professional institutions in Africa. She's been researching on sustainable forest management, livelihoods, poverty eradication, indigenous knowledge, many of the things that we've been discussing. But perhaps, and why I think she's especially appropriate for a final speaker for us, is that she's really now working at a policy level to try and get this out of just research, out of what we think should be done, and into mechanisms that can work on the ground. So Dr. Mutta, Doris, over to you as our guest speaker. Thank you very much.
Wow, thank you so much for that lovely introduction, and thank you for this opportunity to make my presentation. I will not make it so long because some of the aspects have already been presented by Leila, so I'll just pass by those ones. So this is my presentation. Go to slides. Sure. Yeah. Okay. So I'd like to talk about indigenous knowledge systems and agrobiodiversity in connection, and also go specifically even on to tree-based fruit species in Africa, because a lot of the times when you go to agrobiodiversity, we look at the lower level of plants, and trees are not very much highlighted. So I'd just like to do that very, very quickly. And the start of my presentation. No, it's not moving.
Do you need to click in your other screen or something?
Yeah, okay. Yeah.
Okay.
It has gone too far. Yeah, so briefly, Indigenous knowledge system has already been highlighted by the just prior presentation by Leila, and just like to particularly focus on where it sits in the traditional knowledge. I know there's the whole traditional knowledge aspect, but Indigenous knowledge is that part of traditional knowledge held by members of a distinct culture concerning a local geographical context. And when it is passed down from generation to generation, that's when it becomes traditional knowledge. And the concept of biocultural heritage has been well elaborated by Leila's presentation, which refers to knowledge and practices of indigenous people and the biological resources from the genetic varieties of crops they develop to the landscapes they create. You can see in this scheme of the system, we have the traditional knowledge there, then the biogenetic resources are part of that cultural heritage, customary laws that govern the use and management of the genetic resources, and then you have cultural and spiritual values that are really, really also critical when it comes to indigenous knowledge. And then the whole landscape is also part of that biocultural heritage. As has been said by Leila, the Rabbi biocultural territory is such an arrangement that I'm focusing now on my presentation on. So this is the framework from which traditional indigenous people have developed to protect their knowledge and resources in a holistic way that we know the traditional property-based systems have not been successful in protecting. So scientists and biological and social scientists have studied these traditional natural resources management systems, and they have revealed that these systems are so complex and very sophisticated. And for example, traditional agricultural, forest and woodland management and animal husbandry practices are based on indigenous knowledge, have often developed over countless generations, and by necessity have the required adaptation to uncertain environmental conditions, such as periodic droughts. And in the context of climate change, which has exacerbated the vulnerability of these local communities throughout much of sub-Saharan Africa, indigenous and traditional knowledge and practices represent an important element of the adaptive capacity of rural communities, and hence the importance of focusing on indigenous knowledge systems. In Africa, we have about 20% of the population, which is about a quarter of a billion people living within 5 kilometers of forest. And these rely on such indigenous knowledge systems of the knowledge of the forest ecosystem for livelihoods. They derive their food from there, the medicine, and even water and other supplies in order to adapt environmental and economic stress. And this is where we find in our organization at African Forest Forum, it's an area that we find very critical to understand, to know how this ecosystem, this system around this forested are managed, and they contribute to the livelihoods and socioeconomic development. And so my topic is on agrobiodiversity, and I'd like to focus on the traditional agricultural systems as a rich source of such agrobiodiversity. Agrobiodiversity is defined in CBD as the diversity of crops and the wild relatives, the trees, the animals, the microbes, and other species that contribute to agricultural production existing at ecosystem level, species, genetic, and also landscape level. And these are a result of interaction among peoples and the environment for thousands of years, and essentially the contribution of traditional practices, technologies, and knowledge to sustain the diversity. So we have these traditional agricultural systems as being rich repositories of crop genetic diversity attributed to the indigenous technology that have been developed by the farming communities to suit different ecological and socioeconomic needs. Some of the agricultural farming systems are rotation, which are listed here, transitional crops that are used, that are adapted to different altitudes, and including trees and crops. We have agroforestry is one such system, which is a system that involves socially and ecologically acceptable integration of trees with agricultural crops and animals simultaneously in a sustainable manner from a unit of farmland, especially under conditions of low-level technology inputs and marginal lands. Homestead gardens are very prominent in many African households, which are small plots of land consisting of a combination of different crop species grown within the compound, largely grown for food, forming centers from which the rest go to the other production units in the farm. Mixed crop farming is now the extension of the homestead garden to the farmland away from the homestead. And this consists of mixtures of between 5 to 10 species, which reduce the risk of crop failures because they have different maturing dates, mean that planting is spread over a long period as possible, and also harvesting is sustainable. Now, agrobiodiversity systems have, through this, contributed to food systems, security, and adaptation to climate change. These systems, guided by traditional and drought and crop failures, which were occasionally experienced, were also managed to contribute food security. These were mainly fallback plans for drought and crop failures. They are valuable for the nutrient cycling, stability because of the kind of species that are included, and productivity. It supports soil fertility, the structure, quality, and the soil health. They are also important for pest and disease control because they include those species that survive that are resistant to pests and diseases, and that can be used even to support the domesticated plants and hence contribute to ecosystem stability to agriculture. Therefore, for those agricultural economies, for example, in Africa, which are many, the conservation and sustainable use of this agrobiodiversity becomes fundamental to sustainable agricultural development because they support rural livelihood through subsistence agriculture, contributes to national food and nutrition security, and to scientific improvement. Now, going to our study in African Forest Forum, we recently launched some studies looking at the forest and tree-based food species in Africa's biodiversity hotspot. You can see the map of the hotspots all across Africa. We engaged experts from the Guinea Forest of West Africa, specifically country of Benin, the Horn of Africa biodiversity hotspot, coastal forests of Eastern Africa, Makutaland, Pondoland, Albany hotspot, and the Eastern Afro-Montane. Here, these studies have been focused on documenting indigenous and traditional knowledge of forest and tree-based food species that are associated and their conservation status and the uses across different forest types in the selected biodiversity hotspot. And through this, we've been able to gather indigenous knowledge of those forest and tree-based food species that are still being used. We know some of the knowledge has already been eroded, but now we wanted to validate some of the traditional and indigenous knowledge, and we've been able to do that. We also, in that study, focused on the supply and the production trends, and also traditional management practices for sustaining for the forest and tree-based food species across the different forest types. So I'll just go through some of the findings. We have on the Guinean forest of West Africa. These are some of the species that we have identified in literature, and our experts have already confirmed the African bush mango, what we have highlighted in yellow, the one that our experts have been able to confirm as being still food and the level of status. So we have African bush mango here. It's used it's a food product, and it's somehow semi-domesticated and is widely cultivated. We have also Parkia globosa, which is a seed and is semi-domesticated. We have Cola nitida and Garcinia cola, and also Annona senegalensis, an indigenous food crops that is also still somehow wild and with minor domestication. We also had Ansonia digitata, which is the baobab, which is a semi-domesticated, although it's a very important species for food and nutrition, very rich nutritionally, but there's still some work that's not yet been done in terms of its domestication to take it beyond the farm. In the Eastern Afro-Montane, these are the species that have been documented as food species, as trees. I'd like to maybe highlight Tamarindus indica is one such that is fully domesticated in a drylands. We have been doing study on the value chains of this species, and we think it's one tree species that needs to be further studied in terms of developing sustainable business model, because it's a very critical food species that has value, but it's not appreciated at the local level. The value is only mainstream and in the market. We have in the coastal forests of Eastern Africa, we've also documented this species. You can see baobab is still here again, a very important species. And in the Horn of Africa, we have also been able to highlight some of the food species that are still available and being used by the local communities. Madagascar and Indian Ocean, also we can see here, we have Adonsonia is a dominant species in the landscape of Madagascar by diverse hotspots. And in the Karo, succulent Karo, Namibia, we have this species. And so in terms of domestication, these are some of the species that some of them have been domesticated and are part of agricultural landscapes, contributing to subsistence agriculture and supporting rural livelihoods in food and nutrition security as well for the humans and the livestock. But some of these, not all of them, only a few, maybe a small percentage of these are already in the market economy as food-based value chains for domestic and international markets, contributing to rural income and wealth creation for local communities. However, as I've said, more research is needed in terms of developing these value chains for the food product, the tree product that are already being domesticated. And also there's the potential for those that are yet to be domesticated to be fully documented and appreciated. So, and hence the importance of sustaining the indigenous knowledge systems in order to sustain agricultural systems. This system has been highlighted by also Leila. There are various threats to this knowledge system. There's loss of traditions by sectors of the society due to forced or voluntary cultural alienation, reduced dependence for livelihoods, and extensive urbanization. There's erosion due to traditional culture and declining interest. The youth moving away into the urban areas, and they're not participating in those systems. There are also indigenous and traditional forest agriculture management practices are being eroded due to promotion of modern agricultural technologies and using formal-based science approaches to forest and agriculture. So we need to be able, as we develop, use science to develop the agricultural systems, we need to integrate also the traditional system. And also external pressures such as deforestation, land degradation, and resource exploitation, and limited resources are leading to diminished of indigenous and traditional knowledge, and inadequate documentation and preservation efforts for traditional forest knowledge among indigenous communities. You can see a lot of some of the plants are still are threatened because of that. And despite all that, there's still resilience in this system, and we're still able to find this knowledge on the diverse African forest ecosystems and the communities, because communities have developed elaborate social institutions like the Kaya Council of Elders to ensure the maintenance of the resilience of this socio-ecological system. And some have been developed as part of very strong political systems through enforcement of taboos and regulation to control social behavior. Sacred forests are an example. I need not elaborate on those. There's the sharing of seeds between neighbors and friends which formed a sustainable and preservation network for preferred crop varieties, and this ensured continued availability of the germplasm, especially when we have the introduction of the monocrop system. This sharing of seeds has been a very useful of maintaining the availability of the indigenous species. So the cultural and ritual practices are also important, and therefore I'd like to conclude that for those agricultural economies that depend on agriculture, the conservation and sustainable use of agrobiodiversity and the indigenous knowledge system are fundamental to sustainable agricultural development. Thank you.
Thank you very much, Dr. Mutta. We are running over time, and I know that some people will have to leave. I will pass over to Dr. Santoro to give us a last few words, but I will also ask the presenters and anyone who wishes just to stay behind after Dr. Santoro has spoken, and so that we can continue the discussion if you would like. So from my point of view, thank you very much to all of the speakers. Doris, I was struck by your last little comment there. Despite all of these changes, the resilience is there, the people and the systems are resilient, but we do need to support that. So thank you very much. Antonio, over to you, please.
Thank you, Stephen, and thank you to all the speakers for the very interesting and inspiring presentations. I'll try to wrap up the main issues that were raised by these presentations. We have seen very different examples from different parts of the world of landscapes and of techniques and systems where trees are within agricultural lands, and all of these have some common features. For example, the capacity of adapting to different and sometimes also difficult environmental conditions. And these are all examples of resilient systems, particularly rich in biodiversity, agrobiodiversity, so of great environmental value, but also of a great cultural value, since they can provide different cultural ecosystem services to the whole communities, at the same time contributing to food security. However, they are also facing multiple threats. They are under pressure, socioeconomic pressure mainly, but also environmental. And farmers are the ones who actively maintain these systems, and so farmers should receive more support. There are some examples, for example, the ones cited by Teresa, where in Europe, the Common Agricultural Policy started to support financially the farmers that apply and preserve agroforestry systems. It is a positive sign, but more support is needed for the small-scale farmers. But it's a big change compared to the European agricultural policy that we had 20 years ago, that was mainly based on increasing the production and so increasing the agricultural intensification. Some other programs, as the FAO program reported by Professor Agnoletti, is also promising, but sometimes these international initiatives have a limited impact at the local level. Also, the GIAS program, it is successful only where it is where the local community is actively involved and the local stakeholders. Otherwise, it is only a label without any positive impacts on the well-being of the rural communities. So community-based initiatives and community-based management, living labs, bridging together farmers and sciences are needed for the preservation and for also the valorization of the system, because they need to be valorized, the products need to be valorized to make these systems more sustainable also from the economic point of view. I really want to thank again all the participants to the webinar. If some of you have some questions, of course we can ask to the speakers. Some of you requested for the presentations. I ask you to send an email. I write the email address where you can request the presentations, and then we can ask the presenters if they can share their presentations.
Thank you very much, Antonio. So I will pass it over. If anybody would like to leave, of course you are welcome to leave. We are after our official finishing time. However, if anyone would like to continue the discussion, please raise your hand. Press the little react the raise hand button within the react box. And I will take any questions or comments to any of our speakers, please. Do we have any other? Oh, sorry, Mauro. Would you like to speak, please? Go ahead.
Yes, I'm sorry. I was running out of time before, so I didn't have the chance to to explain a little bit better that actually when we finally succeed in making the government give subsidies to the farmer, it was 10 years after the development of this national research on this traditional agricultural system. And so it took many years to achieve a governmental level. But what I wanted to say is that we have a very good contribution from local communities. I mean, when to the farmers, we have been given an alternative to intensify their production or maintain the traditional system, which is a very new thing in a European agricultural policy that was criticized by many economists. I mean, they would say the farmers are not interested because they want to go for production intensification. The reality is that instead, many farmers, a huge amount of farmers, applied for this, and the application compared to the funding offered by the ministry was 3 times the budget. So the ministry was offering this 800 million euros, but they were request for more. And then the last thing is that we were successful in creating a national association of this traditional agricultural system, which is putting together the representative of all the sites that have been included in this national list. So at this point, we have an association that is organizing meeting and dialoguing with the ministry in order to promote this form of agriculture, because at the end of the story, which is my last word, we noticed that according to the economic studies in Italy, the intensive agriculture succeeded only in 25% of the Italian territory. For the rest, instead, is a more traditional form of agriculture, but it has never been included in any political strategy. So at this point, it's good to have research, of course, and all these interesting presentations are fundamental, but we thought that it was time for action. We try to bring this into active policies, also taking care of what the colleague Dennis was saying at the beginning. There is an urgency to go ahead in this direction. Thank you very much.
Thank you very much, Mauro. Misun in Seoul.
Yeah, just a quick response to Maura's, and actually I'd like to highlight this point. I think it is, as we know exactly that we can say FAO, GS, and UNESCO Cultural Landscape designation, it is very valuable, and then we know the multiple service and function of agroforestry to society. But for maintaining this system, maintaining the designation site, we need continuous support, and we need to continuous communication with the communities, and as well as public, that we should have a public awareness how we can add values of agroforestry system to the market, for example. I think we need more practical approaches to improve our awareness for sustainable agroforestry system. So thank you for the opinion.
Thank you very much, Mison. Are there other questions or comments? I'd like to remind us that right at the beginning, Dr. Garrity laid out both the urgency, the need, the urgency, and I was struck by the challenges that he gave us as researchers right at the end. He said we needed more research on the risks of climate change. We needed more research on how to make agroforestry more resistant, more resilient. And also how agroforestry will or might respond if we start working on increasing the reflectivity in the atmosphere. He also called upon us to speak out, and he spoke of the need for a comprehensive plan. I think we saw some elements of all of those across the subsequent presentations. I certainly found that the presentations were positive and helpful. I can't help but wonder, Dr. Garrity, are we going far enough, fast enough? If I can ask you that, please. You're still muted, I'm afraid.
Yes, I was muted. Stefan, we're not going fast enough by a long, long way. And the meetings in COP30 in Brazil just wound up a couple of days ago. The urgency just isn't there. And not only with the citizenry as a whole, but with the people who know more about climate change, the negotiators, the teams from each country that get together every year and discuss what should be done, they are not demonstrating the urgency of the problem. Now, part of the difficulty is that science has been just uncovering very rapidly over the last few years just how fast the temperature of the planet is accelerating. And so a lot of folks are just catching up with that understanding. And that's what I was trying to emphasize to our group today, because it is this acceleration process that is so worrisome for all sorts of impacts, but certainly impacts on agriculture, agroforestry, and forestry. And I'm hoping that we all take that into consideration in our research programs, because things are beginning to change at a very much more rapid level. Stephen.
Thank you very much, Dr. Garrity. And I've been struck by the fact that a number of our speakers have talked about how complex these systems are, our various agroforestry systems, and how they also require very complex management response. We were hearing a lot about how the knowledge in the farmers, in the rural communities, the traditional knowledge has shown the ability to adapt. But I think, as you were saying, the need for adaptation is, we are facing situations that we have not faced before. And I think that becomes for us as researchers, that becomes a moral imperative to contribute to this and to consider what we can do with this. Thank you very much. Other questions, other comments from participants or from the speakers yourselves?
Sorry, there is a question in the chat.
Oh, sorry.
Yes.
Question in the...
which are the relation between permaculture and agroforestry?
From Bayisa. Would someone like to comment on permaculture and agroforestry? Vasil has put a comment into the chat, explaining a little bit the difference there. Vasil, would you like to add anything to that?
Hello, I am from Ukraine, the Ukrainian Agroforestry Association, and in broadly, the agroforestry is a set of specific land use practices that integrates trees and shrubs with crops of livestock, while permaculture is a broader, holistic design philosophy that can include agroforestry as a component. Think of permaculture as a wood why that guides the design of all human systems, and agroforestry as one of many specific practical tools used within a permaculture design to create a beneficial relationship between elements like trees and food production. So permaculture is close to the nature using of territory, and agroforestry is a part of permaculture. This is my view. Thank you very much.
Okay. Thank you very much. Any other comments or questions coming in here? Well, in that case, I would like to say once again, thank you very much, everyone, for participating in this. We have people from all around the world, and we've had an excellent series of speakers. Personally, I'm not an agroforester, so I found this very, very interesting, very, very challenging, and very encouraging. And I can certainly see applications within the part of Eastern Canada where I live. So now I've just got to go and do as Dr. Garrity suggested at the beginning, which is go and speak up and go and get some of my colleagues and say, what are we doing on this? So thank you very much, everyone. And I wish you all the very best for the rest of your day, wherever you are. Working with Antonio and the team and the presenters, we will try and prepare the recording of the webinar, and also to make presentations available, and we will send a message out to everybody who was registered. We did have nearly 200 people who were registered for this conference. The peak number that I noted while we were doing it was was a little over 55 people. So thank you very much, everyone, and I'm glad that we've had such wonderful interest on this. Thank you very much.
Thank you, Steven. Thank you.
Thank you, Steven. Bye.
Thank you.